Pablo, question 1 or 2? Number 2? Remember we have our vertical asymptotes, not set equal to 0, and then our horizontal, look at the powers, and then you simplify or reduce, you're left with 5. There's my horizontal, and there's my graph. Pablo, can you tell me how you fill that in? As? Positive infinity. So Pablo, do you drive yet? Have you seen those crazy drivers in the parking lot? Like they don't care about lines. Well, this graph says you have to kind of like follow the line. So this means that the graph can't go towards all the negative numbers. Does that make sense? It's approaching what number? It's approaching that 5. Do you see that? Did you guys see that? The graph can't go further down. Question? You're correct. Certain graphs can. If you actually use like a table of values, you'll recognize that as you keep going on the x-axis. Let's do that really quick. Everyone say parentheses. I know some students on their quizzes probably input in their calculator 5x, but not with parentheses, and that's why their problem is wrong. So there's the graph. And then as you are asking, like, how do I know that number can't keep going down? Well, if I go to my table set, let's just say we want to start here at somewhere, I don't know, 4 or 5. But this time, let's see what happens. Second graph. What's happening to that number, class? What's happening? The y's are getting closer to what value? To the 5. Do you think it'll ever cross 5? No, let's try a big number like, I don't know. Oh, see? Even at 5,000, it didn't do it. Does that make sense? So it's getting close to that number, it's approaching it, but it'll never be 5. Okay, Pablo, going to the left. As x approaches negative infinity, okay? So now we're on this graph, right? What happens to that graph? Is it going to keep going up? That's a crazy driver, right? Can't go past that boundary. So it's approaching what number? It's approaching 5. Notice how the graph is not going down, it's not going up, but it's on that guardrail. Does that make sense, guys? All right. Cameron, number 1. As x approaches. Yep. And the second one? Yep. The graph's going down. A couple of things I want to highlight. Shouldn't use that color. In your sentence frame here, you will always have one positive, one negative on the x values. Sometimes in different books and situations, they'll actually flip this, and you just read it from the x values. Does that make sense? So they might actually like write f of x approaches blank as x approaches something, and you can just switch it.
Why is the f of x negative in the first one? The infinity?
Here?
At the top.
Here.
Yeah.
So what's happening is your y values are going down. They're all negative. Does that make sense? So here in green, these will always stay the same. Some other observations I want to point out. Notice how these are both pointing down. The graph is going down. So you'll notice that they're both what? They're both negative. So these problems are looking at end behavior. Look at your arrows. If you see any guardrails, that means it's approaching that limit. And you can just put that number in. Okay?